Project 4, Keyword Extraction from Text. Welcome back. In this project, we'll build a keyword extraction tool. Keyword extraction is a helpful NLP technique that identifies important phrases in a document, allowing us to index and tag content for easier search and categorization. What is keyword extraction? Keyword extraction is the process of identifying significant words or phrases within a text. These keywords are typically the words that give insight into the main topics or subjects in a document. For example, in a news article about climate change, keywords like climate, carbon emissions, and global warming would capture the article's main topics. Applications of keyword extraction. Keyword extraction has many applications, including content indexing, where tagging documents, articles, or emails with keywords to make them searchable. SEO optimization, identifying relevant keywords for blog posts or articles to improve search engine rankings. Summarizing content, highlighting the most relevant core topics within large volumes of text. How keyword extraction works. Keyword extraction can be done through several methods, including statistical approaches like TF-IDF, which is term frequency, inverse document frequency, and machine learning models trained to identify important words. For this project, we'll use a hugging face model that can identify keywords directly from text, making it quick and easy to build our tool. Now that we know the basics of keyword extraction, let's get started by setting up our model with LangChain and Hugging Face. So, building a tool to identify key phrases from a document. Here, our objective would be to set up the keyword extraction model and build the core function for extracting keywords. Setting up the model. We'll use a model from Hugging Face that's fine tuned for keyword and phrase extraction. One option is ML6 team slash keyphrase dash extraction dash distilbert dash inspec, which is trained on keyword extraction tasks. Let's start by setting up this model. First, we'll need some dependencies. Make sure you have Hugging Face transformers installed. If not, you can install it with this command. I'm going to run it. Here, I'm going to open my terminal. And instead of creating environment, I'm just going to run it directly this time. No need to create an environment. But if you want to, it's a good practice. So pip install transformers. Since I've already installed it before, it's pretty quick. Next thing is loading the keyword extraction model. Now let's load the model using Hugging Face's pipeline for token classification. Token classification is type of model that assigns labels to each word in a sentence, allowing us to identify keywords. So I'll go ahead and I created a new file, keyword extraction text.py. I'm going to import from transformers pipeline, and then I'm going to load the keyword extraction pipeline, which is keyword pipeline equal to pipeline, and here I'm going to say NER, which is named entity recognition, and my model, which I mentioned, ML6 team key phrase extraction distill BERT inspec. The pipeline function with the NER, which is named entity recognition setting, lets us load models for tasks that label words within sentences. In this case, we're using a model specifically trained for keyword extraction, so it will identify relevant keywords based on the context. With our model loaded, let's create a function that processes text and extracts the keywords. Application for indexing and tagging content. The objective here is to build the function to extract keywords and create a user interface for interaction. So first, creating a function to extract keywords. Let's create a function called extract underscore keywords that takes a text input, processes it with our pipeline, and returns the keywords. Let's go. Here is the implementation for it, where I'm going to define a function, extract keywords, pass it the text. I'm going to run the text through the keyword extraction pipeline by calling this function. Next, I am going to collect the keywords from the model output by saying extracted keywords equal to keyword word for keyword in keywords. That will return extracted keywords. Now the function runs the text through keyword pipeline, which returns labeled keywords as a list. We then extract and return only the keywords for easier use. Next step is testing the keyword extraction function. So let's test our extract keywords function with a sample input. Let's start with an example. I'm going to say text equal to LangChain is a framework that helps developers build applications with language models, including chatbots and question answering systems. Now here I'm going to say keywords equal to extract keywords. I'm going to call the function above, print the text, and then print the extracted keywords. So the output should be a list of keywords relevant to the text like LangChain, framework, developers, and applications. So let's run this and check it out. I'm going to say Python keyword extraction.text.py. It's going to take a few seconds. It'll give me the output lang, chai, and chat, and bots. So it didn't give me LangChain a single word because it thinks lang is one, then chai is another word, and then chat is another word. So that's how it works. So we have our uh, keyword extractor here from this particular text. Now next step in this process is creating a user interface similar to other projects that we have done. To make the keyword extraction tool interactive, let's create a loop where users can enter text and receive keywords in real time. So for the code, I'm going to first create a function main, then I'm going to print welcome to keyword extraction tool, and then while this statement is true, which is always, I'm going to get an input from user until they press the exit button, which if exit text, which is if true, I'll say goodbye, break it out of the system, or else I'm going to call that keyword extract text and print the keyword that comes, and finally run the main loop here. I'm going to get rid of this here because I don't need that anymore because I have a loop which constantly runs. So that's our function here. Now this loop allows, see, so the interaction loop that we have created, this loop allows users to enter text passages continuously. Typing exit will end the session, but until then the tool will extract the keywords for each text input. Now let's go ahead. Next step is example test run. Let's test our tool with different inputs such as, let's see, give some text here. So I'm going to clear this out, run the same file again. I'm going to say in here, Python is a versatile programming language used in AI and data science. If I run it, it says AI, data, and science are the extracted keywords. I can enter the same text that we have used before and see if it gives the same answer. I'm going to say LangChain is a framework that helps. It says Lang, Chai, and chatbots, chat and bots. So there you go. We have that. I can press exit to exit out of this. It says goodbye, and that's it. So with our keyword extraction tool complete, let's review the key concepts and takeaways from this project. Summary and key takeaways. So let's go ahead and review some of the key concepts. In this project, we explored keyword extraction, an important NLP task that lets identify the main topics in a document. We learned that keyword extraction is useful for indexing, tagging, and summarizing content. We used a pre-trained model from Hugging Face that allowed us to implement keyword extraction with minimal setup. Let's recap some of the steps. To build this tool, we loaded a pre-trained model from Hugging Face for keyword extraction. Then we created a function to process text and extract keywords. And finally, we built a simple user interface to make the tool interactive. Some of the practical examples for this. Keyword extraction has a wide range of practical applications. It's commonly used for tagging and indexing content, making large data sets of content more accessible. SEO, identifying important keywords for online content optimization, and text summarization, highlighting key topics to give users a quick understanding of the content. So great job on completing your project 4. You now have a working keyword extraction tool that can be used to identify important phrases from any text. In the next lesson, we'll explore another LangChain project focused on building a chatbot with memory.